And so that's known that these nanoparticles end up in the liver, but if before they end up in the liver, the drug, and the small molecule drug is already released from the nanoparticle, that could be a way to prevent liver accumulation. That's one thing. The other thing is, I mean, if you say there's no liver uptake or there's less liver uptake, does that mean it takes a longer time before it's taken up by the liver because it has to end up somewhere at one point, right?
Yeah. Good. Yeah. So, so the first answer is that the particles will eventually go to the liver. Right? By the time they get to the liver, majority of the drug is out. So what ends up going to the liver because of long circulating particles is that most of the drug has been released. Now, so what goes to the liver is almost like a ghost, just polymeric particles that goes to the liver. So if you look at your release kinetic of the drug, majority of the drug, about 90% of the drug is gone. The platform, the technology that is relevant clinically is gone by about 36 hours, 24 to 36 hours. Most of the drug is gone. The particles are long circulating enough that they might actually circulate for several days before they sort of deposit. So but you remember it's a half-life, right? So the half-life of those particles that I showed you was about 19 hours. And so majority of the drug is gone within 24 hours. Half-life of the particles in 19 hours. So tells you that what goes to the liver is more or less ghost particles. You could create the drugs to be released even slower so that what the liver